Hi, Stephen. Here's a little bit of help for some of the problems that you asked for the converse of the Pythagorean theorem. So I kind of figured some of these would trip you up just because when you have the root of a number, it looks kind of scary, but don't let that fool you. So remember, if we're trying to prove the converse, we're trying to prove that c squared equals a squared plus b squared. So I'm going to assume in this case that this is the right angle and this is the hypotenuse, just because this looks like the right angle to me. And remember that side directly across from it is the hypotenuse. So I'm going to say that this is c. So the square root of 17 squared equals 1 squared plus 4 squared. Now, like I said, this is where I assumed some of you guys were going to get tripped up. This looks weird here. The square root of 17 squared. Remember, to undo a square, you square root, or to undo a square root, you square it. So what we're simply doing here is canceling out the square root and the square. So we're just left with this 17 here. So 17 equals 1 squared plus 4 squared. I know that 1 squared, or 1 times 1 is 1, plus 4 squared, or 4 times 4 is 16. And in this case, 17 does equal 17. So this is a right triangle. Now looking at number 4, got a pretty bad glare there. Let me turn that around. Number 4, again, we're trying to prove that c squared equals a squared plus b squared. So again, we got a square root here, and we're going to assume that this is the right angle. So this is c, so the square root of 29 squared equals 5 squared plus 3 squared. So in this case, again, remember, to undo a square root, you square. To undo a square, you square root. All you're doing is canceling that out, so you're left with 29 equals 5 squared plus 3 squared. Then 29 equals, so we're left with 5 squared, or 5 times 5 gives me 25, plus 3 squared, or 3 times 3 gives me 9. 29, so 25 plus 9 equals 34. In this case, it is not true. 29 does not equal 34. And if you remember, if c is less than a squared plus b squared, then it's an acute. So this is an acute triangle.